लगा नहीं आ रही, ईयरफोन में भी नहीं आ रही।
Hi, I hope my audio and video is visible.
So
Yes.
your audio is there, but not video.
Yeah, I can see you, Jason.
Now you're visible, sir.
Ajit sir, can you hear me?
Yes, I can hear you.
Okay, we'll start. Okay, so welcome to this session. This is Introduction to ROS2. So basically, this session will be like an exposure to robot operating system. And it will be like a brief introduction. So as the name suggests, a brief introduction to ROS. And it's more likely the targeted audience is those who have never heard of ROS or who have just started ROS. So those kinds of people. And of course, if you have used it, then you will gain some or the other knowledge. So before starting, I wish to say about e-Yantra robotics competition. So this e-Yantra robotics competition is a competition wherein we give you and we train you from start. So basically, if you don't know anything, still you know a little bit of programming or you have little bit of hardware experiences, or even if you have nothing, but we train you and then give you the task in a parallel way. So we can see the timeline a little bit. It's more like a 7 to 8 month long competition. So it starts on August, the registrations, and then from September to November is the stage one. So in stage one, it's basically about simulation. So simulation task will be given to you step by step, like a small task of programming or a small task of image processing things with learning resources as well. So that using learning that resources and doing that small task, you will be able to complete the final theme. So we'll go into what is a theme and all that. So after stage 1, in stage 2, selected teams, that is the top teams, will be given hardware access. So we'll be giving you hardware kits, will be supplying or shipping to your address, and then hardware task will be starting as task 3, 4, 5, 6 will be like the hardware task. And of course, on the finals will be conducted where a special task will be given and you have to complete. And on that completion of that task, top 5 teams will be called to IIT Bombay to perform that. So I will show you a mashup film, which so this does. I'm not sharing the audio, but I will explain you step by step. Like basically, this is a Krishi bot team wherein students have to pluck the fruits in a greenhouse environment, and then they have to simulate it at the same time. So they were given remote access. So this one is like a drawing robot, but at the same time it can move at any direction because of holonomic wheel. And then comes the drone theme, wherein drone was shipped to students and they had to geolocate this particular yellow block and all the obstacles which are on the scene and actually share the coordinates with respect to the latitude and longitude. So that was like a GNS as well as drone combination theme. Then comes a delivery bike, wherein control system is used. So a self-balancing bot is made using uh, using any designs, freedom of design given to the students. Then comes Swachhta bot, which is using FPGA. So you will be learning more about field programming, gate array, and things. Then comes functional robot, where functional programming is used, and at the same time, you are able to solve a task like pick and place and algorithm to find the shortest path. Yeah, that's it. So the prizes for after the robotics competition is like, of course, you will get a certificate of various levels based upon which task you were able to complete. Then cash prize, goodies, and as well as 8-week paid internship. So you those selected after some interview rounds, you will be able to come to IIT Bombay and do internship, and then we will be paying you. Yeah. So this is the website, portal.e-Yantra.org. You can go into this website and then get to know more about it. So now coming to the ROS2 part. So as the word suggests, robot operating system. So this is more like an operating system, because in operating system you have the functionalities of scheduling as well as managing multiple things. But developers face this problem whenever they want to create a new robot, or let's say you want to create a four-wheel drive robot, and then you are working with a manipulator, you are working with a image processing thing, then suddenly you are creating a humanoid robot. So for everything, writing a separate section or separate things was a very tedious task. And also at the same time, to manage network, to manage inter-process communication and all that. So that's how the birth of ROS started. So so we will go into much more detail. But before that, let's discuss about what a robot or how it functions. So functions in the sense a little bit detailing about it. So a robot, when you think suddenly, this is the picture which has come to your mind: a humanoid robot which has eyes, ears, which can move and do some pick and place stuff. So let's say, and for example, this robot, this has sensors like camera, and then microphone to hear what we are saying or to sense the environment, and then speaker as well as actuators, and then things to do based upon the vision it's getting. So it needs a processor inside. So all these things are in this robot. So what makes it amazing is this uh, is combination of all of this task is what making it feel like a robot. So what major thing is like to communicate between each of the things. So vision should say, okay, to detect, I have detected this, I have to go to that place. But now to communicate this with another script which you are writing, is where this concept of ROS comes in. So we'll go into more details. So first of all, like about ROS. So ROS is an open source framework or platform where you can get all the code which other people have written, and you can know how the internal working of these things is working inside a computer. So let's say you have installed ROS in your laptop, and now you want to tweak a little bit about how the internal working is actually being done. You want to uh, change a particular thing of a minute thing of the communication between each of the nodes or each of the scripts which are happening. You want to tweak and little bit change according to your functionalities or your hardware. That also you can do, and at the same time you can contribute into it, saying that it's your personal contribution at the same time to the open source community. Then it's a easy to use framework. So most of the contents inside ROS is more like plug and play. So you install a particular package, and let's say for detecting red color fruits, and then sending a message onto a particular display. Uh, if there is a package available, you just download it and just change the parameters. It is ready for your laptop. Then similar way, you download that package for your small rover, which has a computer, let's say a Jetson or a Raspberry Pi or anything, and it works the same manner. You just have to tweak the parameters. That's it. You need not to write everything from scratch for each of the robot. And then of course it has collection of tools. We will be looking into it, what are the tools it has, and yeah, and it provides simulation and visualization tools. So we'll be going into each of this in depth. But if you see on the image which is on the right side, you can see two separate window. On the left side, it's a simulation environment, so which has physics and everything. But at the same time, robots need a visualization tools. So what the sensor is looking at, where the sensor is exactly, what are the readings, and if let's say a camera is seeing something, I want to see it on some particular software or particular place with respect to some of the frame. So that is where visualization tool comes in. So the right hand side, what you are seeing is actually visualization tool, which we'll talk about in the later slides. Yeah. So coming back to the question, why ROS? So main things as we discussed, modularity and reusability. So I have written a code for this particular humanoid robot. I can in fact use that same particular thing in a smaller robot or a smaller four-wheel drive robot for a particular thing. So if a line following thing which you have generically written for a big hotel robot, which is using a line following, you can use the entire thing and use the same functionality or the same package for a small robot which uses an IR sensor. So you just need to tweak the parameters a little bit, and that's it. It works perfectly. Now comes the other point, that is global community. So if you would search on Google about ROS, all the details and everything you can find it on the internet, is actually been done by all the students and enthusiasts and the hobbyists, as well as teachers and industrial people who have been working on this domain. So all the community support is available. So if you have a doubt, it might be already resolved by some person, or if you put a new issue, that can be solved by multiple people and they are ready to help you. So at the same time, there's a multi-robot communication. So let's say you have a fleet of robots or a manipulator, and at the same time a robot. So a rover which is having four-wheel thing and a manipulator. You want to communicate between them, saying that you have picked a particular thing and then you have to place it on the robot, but you have to tell to the robot. So this multi-robot communication, instead of straining in your head thinking about how to communicate between this, like you need to set up a TCP protocol, you need to do network settings and everything. It's not needed in this ROS. You just need to make sure ROS is installed in both of them, and then you are on the same Wi-Fi or same wireless network. You can directly communicate between as many robots as you want based upon the network strength. Then multi-platform. So let's say your laptop is in Linux, Ubuntu operating system, and then you have a robot which is having again another Linux kernel based operating system, and you have another laptop, your friend's laptop, which is on Windows. But even though they are multi-platform, you can still communicate using ROS. So this is the amount of flexibility it gives, and at the same time, there's a language flexibility. So, for example, if you have written a particular script in Python, and there is another script which is running in the robot using C++, or a normal robot which is a small robot which is using Arduino and it's working in Arduino API based C programming language. It doesn't matter. All kinds of abstraction and programming are taken care by ROS. So this is a small video about cosmologistic theme. So I will just briefly explain what this theme was about so that you can get an idea of where this ROS is used. So in this theme, they had to identify boxes are based on Aruko IDs and then pick and drop in the conveyor belt. So these boxes are bought by the rover, which is moving here and there. So if you can see, the rover attaches to the rack, and the rover's duty is to bring the rack in front of the arm. So a parallel thing is going on. So first you learn in simulation, and then we'll give you the remote access and to do the same in hardware. So you can see the docking part, and of course this arm needs to know, or the manipulator needs to know, that the robot has docked in front. Then only it can go into the next step of picking the boxes and dropping it. So that is where this inter-robot communication or multi-robot platform, which is provided by ROS, is very helpful. You need not to you need not to learn more about networking and more about script management and everything. That ROS will take care. You need to only focus about the algorithm. So yeah, similarly in another theme which you might have seen in the introduction, that was hologlyph bot. So here you can see multiple robots are there, and you need to draw a pattern and everything. So this communication between each of the robot, and as well as which actuation, what to take care. So you can majorly focus on algorithm, and rest of the communication is taken by ROS. Then comes luminosity drone. So especially in the case of drone, to send communication data and everything, this ROS is very helpful. So you can see in this particular theme where they had to identify alien based object using IR camera, and then to locate and give it as a topic or as a message to the computer that this is where I located. And of course, you to learn all the control system thing. This is a beautiful platform. Like, you need not to tweak around for each of the drone, like the parameters and everything. Rather, the platform is ready. When integrated with ROS, you can directly start tuning it and start trying out your algorithm based upon where to go, how to plan the path and everything. So I guess you have got an idea of why ROS is needed. Now, to cover it in a different aspect, like why learn this? Because industry standard, so many industries use this, even though they use the concept of ROS for, it's like the best thing for prototyping. So if you want to suddenly create a particular robot, and you want to make sure your prototype idea is a proof of concept is ready. So for example, you decided to make a robot which does vacuum cleaning in your house. You have an idea of how to improve the vacuum cleaning part, but you are not interested in going more into detail of how to do mapping, localization, and navigation inside a room. So you download a package of navigation, put it on your robot, and then you only focus upon that particular part of vacuum cleaning. So that way your prototype part is speeded up. Then comes the career opportunities. Of course, since industry is using, you have more and more opportunities in career. Then the research and innovation. So whenever, as I said, if you have a specific topic to be researched and innovated, then you can make a robot using ROS and such a way that your focus is entirely on that particular thing, and you need not to take care about the networking and other aspects. So now coming to the key features of ROS. So it's like a pluggable middleware concept. So communication flexibility, like for example, you need not to worry about the settings of the network. If there is a lag and things, you can directly adjust it at the same time. You need not to tweak it a lot or write it from scratch. So that's a plus point. Then comes like applications, which is like very time critical. You need to communicate faster between the nodes, but at the same time uh, you have many of the robots, so writing script for communication is a bit tedious task, and that's where ROS helps. So ROS2, which is the second version of ROS, has enhanced debugging and logging things. So we will see the major difference, that is DDS, data distribution service. This is like the main thing which was included in ROS2 and compared to ROS1. So one thing to notice is ROS1, it was more like a master slave kind of setup. So master node will be there, and then there are multiple things which are attached, or multiple robots or multiple laptops or whatever. Multiple nodes are connected. So the problem was, if master dies, then there is no communication happening in between each of the things. So that is where DDS is introduced, that is data distribution service. This can work without a master. You just need to be in network, and you can start making yourself public. Like, I am here, you can send me data on this particular topic or things, and I am sending data. So anyone can come and discover that particular node in if you are on the same network. So this was a major change coming from ROS1 to ROS2. So this is a middleware protocol, as said earlier, and it's based on publish subscribe communication. So it's like you publish and you subscribe. So it's like a YouTube channel. You can think of the analogy of a YouTube channel. You publish something and then publish a video, and all those who have subscribed to that particular channel gets the data. Then comes supports of quality of service. So the fact was, in ROS1, you cannot tweak so much on how to control the latency. So for example, if there is a latency in the network and you want to tweak around, what if the packets are lost, how to manage that stuff, or if a packet comes in faster speed, or like it's taking too much bandwidth, or let's say too much data is on the pipeline, then how to manage and all that, you can directly change the settings in this DDS thing. Then comes a real-time control. So it's actually used more in like edge cloud communication. So for example, you have a small node, like a robot which is staying in the room, and it needs to be only activated, and the fleet also has to be activated. So this robot can suddenly, since it is on the same network, start communicating without taking care of if the master is alive or not and all that thing. And of course, this DDS has a across platform uh, uh, help. So it's like, even if you are using Windows, even if you are using Ubuntu, it can directly help you without even worrying about if it's on the same platform or not. So now let's look upon the communication methods. So communication methods are basically like how to communicate between two nodes. So node is like one particular node can be, for example, an image processing node that's taking camera feed and then looking upon what an object is and where to detect, how to localize it. And then there can be another node which is running to how to pick that particular object, which path to be planned and everything. But you need to communicate in between them. So what are the different types of communication methods is what we are going to look at. First of all, it's topic-based communication. So as I said, you can think of a publisher-subscriber method in which a node can act as there is a topic, and on that particular topic, you can publish and another node can subscribe. So let's say a topic name is there, e-Yantra, and a node can come in and say, I publish data to e-Yantra, and all those who have subscribed can immediately get the data. So that is the beauty. In fact, node can be one to many as well as many to one and as well as many to many. You can see in this video, like the message is passed from one publisher as well as it can be taken by many subscribers. So many subscribers can exist at the same time. Also, many publishers can exist at the same time. So it's all about the topic name. So if I wish to publish a particular data on topic, and my friend also needs to publish a particular data on topic, it can be possible. And at the same time, all the ones who have subscribed will get the data. So now comes a problem. But what if, or how to know that the subscriber got the data, or based upon some service if you want. So for example, if you want one thing to be done, and I also want to know that if that thing is done or not. So using this publisher subscriber model, using topics, it's little difficult to do that. You have to make 2 or 3 topics to do that. So there comes the communication method called as services. So in this case, what happens is the client request for something to be done, and the server responds, okay, I have completed this task or I have not completed this task. So with this, you will get to know, for example, if you tell a robot, move to this particular position, and you don't know, you are just waiting if it has done or not. But using services, you can, once you have given the request, after the robot has reached to that particular position, it will give you a response that yes, I have reached this particular position. Or if there was an obstacle, it can directly say, sorry, I could not reach. So this is where the service model comes into picture. Now actions. So if you have seen or observed in the previous part that in services, there is a problem of, if the robot, I command a robot to go to a particular position, and then I am waiting. I don't know what's happening currently with the robot. I need to wait the whole time to know if it has reached or not, or if there is a problem or not. And what I could get at least or at most is the response. So there is the point. Here is where action comes into picture. That the moment you send a goal request, or where you have to go, or what you want it to happen, so that is a point where a response comes in, and at the same time or in the meantime, when the action is taking place, a feedback topic is getting communicated. So the robot will continuously tell you, I am at this position, I am at this position, this is my orientation, and my velocity is this particular thing. So you can get to know that where it is actually stuck and all that things. So this is a very helpful thing, especially in terms of navigation, as well as all kind of things. You can, for an example, you can, if to suddenly relate, you can take an example of your food ordering thing. So if you have ordered a pizza, the moment you order to the moment you get, there is a tracking system. You get to know which part it has completed. You have complete the food is being baked, it's being packed, it's being delivered, it's on the way to delivery. So all the things you can get, and this is where action mimics that particular concept. So now let's look upon the ROS tools. So ROS provides various kinds of tools to, when you are working with this robot, or any kind of robot, or even in fact between systems, you are dealing with the algorithms and all. So these kind of tools are very helpful. So first of all, an example of Gazebo. Gazebo is a simulation software which has huge support for ROS. So if you see, it's actually an open source 3D simulation software, and it has all the physics engine. So the one which are commonly used, OD, Bullet, and all that thing. And it helps you to mimic all the physical forces. So for example, if a box is kept on a robot, it should not fall down, or you have to add friction or things like that. You can mimic it in the this particular simulation software. Then comes custom plugins. So plugins are something like, if I want to mimic something which actually is in the robot, I want in the robot, but cannot be directly done because in the simulation it's not how it is. So for example, I want to pick fruit, But picking a fruit, when we are saying in the real hardware, it's easy. You just pick and the object detaches. But in the simulation, to mimic that, you need a plugin. You write a plugin, which is like a short code which activates on request and does things based on request. So you can attach that plugin on a particular fruit or a particular thing, and then it activates only based upon, let's say, when you put some amount of force. So if you put some amount of force, then only it will detach and attach it to your manipulator. So that is a role of plugin. And then you can create wind or noise or even fog like things and everything in this simulator. Now comes the robot visualization tool, that is RViz. So this helps to visualize your robot. So for example, which frame of reference you are currently looking at, or to if you have located something, then how is that with respect to what distance it is with respect to a particular frame of reference. So that all can be done using this visualization tool. It's more basically important for how the sensors are looking in with to the world. So for example, you attach a camera into a drone, and in the simulation you can see the camera video separately as well as how the drone is moving and things. But at the same time, you want to know that with respect to drone, what the camera is looking currently and where it is overlapping, and uh, at, if I have detected something, where is that coordinate and how much far it is, what angle it is at, what are the locations, and all that things you can get using RViz. So you can visualize all kind of sensor data, even text or numeric or image or a 3D model inside it. And in fact, you can visualize everything using RViz. So for example, you are in a self-driving car and you are mapping the whole environment. So you can create a map, a 3D map itself in this visualization tool, and at the same time see how it is changing or how the things are getting connected, if there was a gap in between when you were constructing a map or not. So yeah, moving to the next tool, that is RQT graph. So this is more like a graphical way of representing how each node is connected. So nodes are like a particular function which is going on, as I told him before, like for example, an image processing task and a navigation task. So how are the communication? A topic is used. So if you see here, a turtle sim node is there, a blue color thing, and there is some other node, and in between a topic is getting used. Turtle one pose, if you see a red color box is there, rectangle thing. So that in that topic, from the turtle sim, something is getting published to a ROS2 CLI. So there are two nodes, one is turtle sim as well as ROS2 CLI, and this turtle one pose is being used for communication. So using topic, it is ROS2 CLI is subscribing and turtle sim is publishing. So using this, you can easily debug what is happening in your robot system. So if multiple robots are there and you want to suddenly figure it out from where to where the communication is happening, or from where to where it's actually not happening, and realizing, okay, this is the place where the communication is not established. So you can quickly diagnose these things. Next is something not so important, but at the same time important when you are doing prototype or testing. So this is ROS bag. It kind of, you can think of as a logging thing. So it's like you are logging the data into a whole set of file, and where you can use that data later to analyze what was happening during that system when it was running. So for example, you have a drone and you are planning to use ROS to navigate based upon things which it has detected, but at the same time moving, completing goals, like flying from point A, B, and C and D and coming back to home position. But you want to know what happened in between, which topic communicated what at what time, and what are the data which has been going on. So for that, ROS bag is useful. It stores all the data, and you can replay it later. In fact, if you have a simulation data, like if you use Gazebo and you store each and every topic, then you can replay it and see how the robot was running later onwards. So let's say if you were running a script, you wrote a Python script and a robot was moving on. And then if you want to later see how it was actually working, you can record that using ROS2 and later take it in your computer and just play it. And it will exactly move as it was doing when you were running your Python script or any of the programming language script. So now let's look upon folder structure. So this is something little important, that how to create a folder inside or a package. So as I told you about the package things, like for example, if you have an image processing package, and that package is responsible for detecting red fruits and say telling you the uh, location of that fruit. So this package is responsible for um, taking camera feed, then doing all the detecting stuff, and doing mathematical computation for locating it and giving you out it on a topic. So this package, if you want to create, or if it was in your computer, or if you install, how it looks and what are the component inside is what we are going to look. So yeah, if you see, there are like five major things. Like in fact, there are additional things also. So first of all is like an include folder. So include folder is like it stores and shares all the header files. So all the code, whatever code you have written, if it requires some header files, or as well as whatever it is generated are related to header files, you can keep it in include. And that is majorly what include folder is all about. Then comes the src. Here you store all the source code. So the main logic of Python code or the C++ code which you have written, that can that is this is the place where you store the src part. And in this place, for example, you have written a mathematical program for detecting or exactly locating the fruit, the centroid of the fruit or the width of the fruit and everything. And that you can easily you will write that particular code here. And then how to uh, process it is what we'll look in later. So package.xml is something which describes more about the package. It's like it's like a metadata for that folder about what each of the package is. If let's say if this particular this whole particular package requires some other libraries or some other packages as well. So let's say this image processing thing requires a library called as math to do all the mathematical things when in communication between each other. So you can tell the package inside that package XML that these are the dependencies it require. Then comes cmakelist.txt file. So this contains the build instructions. So for example, when you downloaded the package, you have to build it to make sure all the libraries are done, and some things needs to be uh, so for example, if you have written a particular code, but you want it to be compiled after compiling some other code, so you can write exactly here how to compile it. So I want to first compile this particular script, and then only you should go ahead and compile this particular a B script. So after doing A, only move towards B. Or if you are doing C, then A and B should be completed. But at the same time, I should make sure that other files or other libraries are also needed. So all these things you can make sure in CMake list. Then comes setup.cfg. So it's mainly for Python based nodes to configure installation, like how to do installation for particular Python node, that it requires these particular dependencies. Then I have to install that into my computer. So how to do that is everything is written in this setup.cfg. Then comes Qualcomm workspace. So this is where collection of packages is there. So let's say you can take src as another folder in this workspace. So workspace is like this is where you are going to work, and it has a collection of packages. So it can have itself a package of image processing, navigation, manipulation all together. and then keep it as one set, and then you have a separate folder called as build. So this build has all the compiled files. So let's say script was there, like a C++ script, but you need to compile it, and you compile it and store it in the build, and also any object files. So you need a file which needs to be shared between different nodes. That happens in build. So whenever you are building, as we discussed earlier, using the cmake list instructions, based upon whatever instructions are there, after building it goes into this build folder. Then comes the install folder. So this is where all the after building and things, the software or whatever things which you wanted to install is actually installed. So after here is the place where actually the ROS, whenever you write a command on terminals, for let's say you wrote ROS, you have to run this particular file, which is actually inside a package. So the moment you write a command like this, you are actually going inside the install folder and looking where is that package, because I have something which is already built and kept there. So the ROS, so basically whenever you write that command, ROS directly goes and checks inside this install folder. And comes the log file. So this log file is basically all the log which happened when you were building these things. So whenever you were building this particular packages, if there was an error, or if there was some warning that this particular library is missing, or this version is there is actually a mismatch in our version. So all these details are kept logged in and kept it inside this log folder. So this is very helpful when you are, for suppose you made a thing for a particular laptop, but now when you are trying it in a different laptop, that package is not working, and you found out that there was some internal thing which went wrong and it was not supposed to happen. So you can directly check in the log file and see, if was I missing some dependencies which I didn't write it in the cmake folder, cmake file. If I would have written, then this error would not have come. So all that things you can get it in the log folder. So these are the references which I took. Like you can refer more from docs.ros.org website. Yeah. So now we can switch to questions. So maybe I will enable the chat. Yeah. So you can ask your queries in the chat section. No, the robotics competition registration starts very later. Like for example, as I said in the beginning, it starts in the month of August. So we'll be having the quiz after like around 5:50. So meanwhile, we can take up questions. The main difference between ROS and ROS2 is like, as the in ROS1 there was a master node, so you need to actually have this master node all the time. So when this master node is somehow not available or crashed or there was an error, the whole system collapses. So in ROS2 this is not the case. In fact, in ROS2 there is no master. Okay, complete the competition with lectures. Yeah, so basically learning resources and everything will be given to you, so you need not to worry about it. What ROS2 version will be used? Yeah, we'll be using the latest one based upon whatever support is there. So it's not like the support also needs to be there. Like when you are searching for some error in the internet, when we are giving some task to you, if there is an error, and it should not be like you are searching on the internet and the ROS version has just came up and you're not finding much help there. So something which is in between, like it's latest, but at the same time support is also there. Commands and file structure once again. So yeah, so basically the file structure is more like there are packages and the collection of packages is the workspace. So in each package, there is a build instruction with respect to whatever files you have. So let's say you have a set of scripts you have written, but you have to write a build instruction uh, that is you have to install this particular dependencies, this all these particular instructions is there on the build, and there is a XML file which says more detailed about who made the package and what are the things it actually does and all that things. So that's how a package is made, and the collection of packages is actually a workspace. Yeah. Nodes and topics. So nodes are basically like a particular script you can refer. For example, a script, the whole purpose of that script is to flash a text on the screen. So that node will only flash a text on the screen when another node is sending some data, or based upon some fire alarm, it's flashing a text. So this fire alarm or something can be communicated using topics. So topics is the one which communicates, takes the data from something and publishes it, and the node which is flashing the text will subscribe to this all the time. Whenever whenever the text comes, it just flashes on the screen. So that particular script which is responsible for doing that is the node, and the thing which is used for communicating is called topics. Yeah. Is there any disadvantages in ROS2? Yeah, there are still disadvantages. For example, you need to do that setup. That installation phase is still there, but yeah, compared to manually writing for each and every robot, it's better. You can use ROS2. Everyone participate in competition on individual level. Not It's not an individual competition, so at least a group of 2 should be there. Maximum it can go up to 4. Yeah, there is a small fee. How to initiate ROS2 in Windows? Yeah, you can get the guide from ROS website. You can go in and it will show you detailed step of how to install ROS in Windows. Is it difficult to convert something from ROS to ROS2? It's not very difficult. That is the advantage of ROS2 also. So for example, there was a ROS one script or one based node or a robot, and another computer is there where it is everything in ROS2. So you can install something called as ROS2 bridge, ROS1, ROS2 bridge. So when you install that, it can take all the topics and convert it into the format where ROS2 can understand. So this bridge acts as a help. Okay. Yeah. Then application of ROS2, as I explained, wherever you see that multiple things needs to be handled at the same time, ROS2 is very beneficial in terms of robotics. Is knowing Linux important for working in Gazebo? Not exactly. You can do it in Windows also, but more of the support or more of the content are available in Linux based operating system. Okay, concept of action. Action is more like, so if you understand the concept of services are like, uh, if you send a particular task to a particular robot and you want something to be in return, so that is where, like, you need to know that if the task is completed or not. That is where services comes into help. But the action, how actions help is when you have told a robot to do something, and meanwhile you are waiting for a particular response, you can get to know a feedback, like, I have reached at this particular position. My coordinates are 1 comma 1 and my velocity is this particular thing. So all this can be communicated at the same time without just blankly waiting for the response. So that is where the concept of action comes into help. Key features of ROS2, mainly there is no master node. And of course, you can in fact tweak every little part of the networking thing in your system. Okay. DDS, as I said, it's a data distribution service thing. And moreover to it, it's more like uh, the service which it provides. So it suddenly acts as a middleware, and at the same time, you can randomly come and make it itself as a discovery node. So a node comes in, it can act, say that I am present here. You can send me subscribe. I can subscribe to particular data and publish, and all the other nodes can and come to know that this particular thing exists. So that is where DDS helps a lot, and at the same time. It provides you a faster communication medium, so a reliable communication medium, in fact, reliability in terms of all the packet flows as well as the pipeline management and everything. Okay, why do we use Qualcomm build? So Qualcomm build is basically that workspace to be built on your system. So whenever you are building that collection of packages, to build and store it in the install folder and everything is what Qualcomm build is used for. Okay. Yeah, it's okay that if you have dual booted, that's fine. Like, uh, that's like it's a help because all of the support is found in Linux based operating system. Although in Windows you can find, but the support is less. Okay. To work on project in ROS, but there are too many errors. Yeah, like in the start, you might see some errors based upon how familiar you are. But of course, that is where the support comes in. The moment you paste that particular error in the internet, you will get to know why you got that error and how to, in fact, solve it. Most effective way to start learning ROS2 is basically going through the docs.ros.org website. So if you go into that website, there are like step-by-step guide from beginner to advanced level of what are the tasks or projects you can try and use that to learn yourself. Mm, no, ROS1 and ROS2, the major difference is the master node as well as the DDS middleware which is underneath. So this DDS middleware will help you to navigate to send communication without a master node as well as have a reliable communication. So in the underneath, if you go to the architecture level, there are many things changed. But if you see in the over on the top layers, there is nothing much difference. Like you can run the same idea of having packages, workspace, as well as topics, services, and actions, both in ROS1 and ROS2. But ROS2 is more reliable in terms of multi-robot communication. Yeah. Is there any course available with certification for robotics? Yeah, there are multiple course. In fact, a ROS-based course will be released by e-Yantra soon, so you can check out on that. But at the same time, you can get many YouTube videos and as well as different websites which are offering ROS related. And for robotics, if you are interested towards the mathematical side, you can in fact go and check out uh, all the topics related to robotics in NPTEL videos as well as multi-robot systems and all that things. You can get it on YouTube for free, in fact. For certifications, yeah, you can check out Yetra's website as well as many of the online learning platforms. You can easily get it. For understanding turtle sim and PID controller, In fact, for there are coming sessions for control system and PID controllers. So you can go and check in the website where you can get to know that uh, what are the next talks. So in that there is a talk called PID controlling controller. So you can actually check that out. Yeah. Which programming language? Any programming language, in fact. Majorly it supports Python, C++, and Rust. So Rust is something new which you can also explore. Yeah. Yeah. So now let's move on to the quiz. But before that, let me, yeah, I will share the quiz link. So yeah, for all those who are in WebEx, since we are short on time, I've shared the quiz link. I'll share it again. Yeah. So you can start answering the questions based upon the score and the amount of time you have spent in the meeting. The letter of participation will be given. Google Forms. Okay. So before that, okay, let me check the access then. Yeah. So you can check now. The access is granted. Just to reload that page. I will just paste the link again. Yeah. Just let me know if it is open. Okay, fine. So there's just 5 minutes for it. So it started at 5:52. We'll close the link at right after 5 minutes. So at around 5:57 or 5:58, we'll close it. So make sure to submit it uh, before time, so that
Sir,
there
where
is
is the
no
use link?
problem with the your submission. Then the next talk is about micro ROS. So you might be wondering how to do ROS or how to create something for microcontrollers like ESP32 or in fact you can do for ESP32, but majorly for, like, let's say Arduino Nano or an Arduino Uno or something, and that kind of things which you have heard of. How to do something with ROS2 in that, because how this entire ROS thing cannot be implemented, but at the same time you want something to be mimicked of related to publish and subscribers. So for that you can register for the next talk, and that will happen again on next Thursday. So yeah, for YouTube, thank you for all the audience. You That's it for the live session. The quiz link will be open, and it will be closed within 5 minutes. So around 5:57, the quiz will be closed. Make sure to submit it before time, because once the quiz link is closed, it will be you will not be able to submit. Make sure to use the same name which you used in the WebEx and the same email ID which you used to register for WebEx. And yeah, thank you.